Hello everyone, welcome back to my channel. I hope you all are feeling great and ready to learn something new. So today we are starting a very important and interesting topic in chemistry, that is valency and how elements go together to form chemical formulae. So let's get started. Have you ever think why sodium and chlorine combine to form NaCl, or how we know what elements go together in a compound? Well, it's all start with understanding valency. Valency is the combining capacity of an element. In this video, I will explain valency in a simple way and then show you step by step how to write correct chemical formula using the cross method. So let's first understand what valency actually means. So, valency is the combining capacity of an element. In simple words, it tells us how many atoms of another element it can combine with. It mainly depends on the number of electrons present in the outermost shell of an element. Outermost shell of an atom or element. So, every element tries to become stable by either losing, gaining, or sharing electron. And number of electron it needs to do, that is called valency. So, it is the number of electron exchange of an atom is willing to gain, lose, or share during chemical reaction. In another way, you can say it's all about achieving stability to achieve a stable electronic configuration. You can also think valency as hands. Now that we understand what valency is and why element combine, let's move to the next important concept, the octet rule. This rule helps us understand why atom gain, lose, or share electron in the first place. So let's see what the octet rule says and how it connects to valency. The octet rule is a basic rule in chemistry that explains why atoms combine the way they do. According to the octet rule, atoms try to have 8 electrons in the outermost shell to become stable, just like noble gases. This makes them chemically stable and less reactive. That's why atoms either lose, gain, or share electron to complete their octet. Now, to make this easier to understand, let me connect this concept with real life example that you can relate to. Imagine an atom is like a person at a party and they have a plate. To feel happy and satisfied, they want exactly 8 of their favorite snacks on the plate. Some people already have few snacks, like 7, and need just one more to complete their plate. Others have too many, say 1 or 2 extra, and are willing to give away to reach exactly 8. Atoms behave in the same way. They gain, lose, or share electron so that their outer shell has exactly 8 electrons, just like someone trying to get 8 snacks in the party. This is what we call the octet rule. The tendency of an atom to complete 8 electrons in their outermost shell to become stable like a perfect snack plate. Now that we have understand the octet rule with a fun real example, let's look at how it actually works in real chemistry. As we know, Noble gases are naturally stable. Noble gases like helium, neon, argon, they are they all are naturally stable. Helium has 2 electrons in the outermost shell. Neon has 2. Electronic configuration of neon is 2, 8. So there is 8 electron in the outermost shell of neon. And argon has electronic configuration 2, 8, 8. So there is also 8 electron in the outermost shell. So helium follow duplet rule and neon and argon follows octet rule. This will help you clearly how atoms follow the octet rule to become stable. Like sodium. Sodium has atomic number 11. Its electronic configuration will be 2, 8, 1. So there are 1 electron in the valence shell, or we can say 1 electron in the outermost shell. It loses that 1 electron to get 8 electron in the next inner shell to becoming stable. If we are taking an example of chlorine, chlorine has atomic number 17. Its electronic configuration will be 2, 8, 7. As we can see, there are 7 electrons in the outermost shell. It tends to gain 1 electron to achieve stability. So this is how the octet rule helps explain the formation of chemical bonds and the valency of elements. So the valence shell is the outermost shell of an atom. It plays a crucial role in chemical bonding because the electron in this shell are the ones involved in forming chemical bond with other atoms. So how we calculate the valency of any atom? If an atom has tendency to lose its valence electron, then its valency is equal to the number of electron lost. Like in case of sodium, sodium has 1 electron in its valence shell. So it tend to lose its 1 electron to get stability. So its valency will be 1. If we are taking an example of magnesium, its atomic number is 12. So according to noble gas electronic configuration, its electronic configuration will be 2, 8, 2. So there are 2 electrons in its valence shell. It tend to lose its all 2 electron to gain stability. So its valency will be 2. If an atom has 5, 6 or 7 valence electron, it tend to gain electron to achieve stability, making its valency 8 minus 7 is equal to 1. Like in case of oxygen, its atomic number is 16. So its electronic configuration will be 2, 8, 6. So there are 6 electrons in the valence shell. Then how we calculate its valency? 8 minus 6 is equal to 2. So its valency will be 2. If we are taking an example of chlorine, its atomic number is 17. Then its electronic configuration will be 2, 8, 7. So there are 7 electrons in its valence shell. It tend to gain 1 electron to become stable. So how we calculate its valency? 8 minus 7 is equal to 1. Its valency will be 1. If an atom has 10 to share its valence electron, then its valency is equal to its valence electron. Like in case of carbon. Carbon has atomic number 6. Its electronic configuration will be 2, 4. So there are 4 electrons in the valence shell. It tends to share all its 4 electrons with other atom. So its valency will be 4. In case of silicon, Its atomic number is 14. So its electronic configuration is 284. So there is also 4 electron in the valence shell. It share all its 4 electron with other atom to get stability. So its valency will be 4. Here I am sharing few more examples like potassium. Atomic number of potassium is 19. Its electronic configuration is 2881. So there is one electron in its valence shell. It tend to lose its one electron to get stability. Its valency will be 1. In case of fluorine, atomic number of fluorine is 9. Its electronic configuration will be 2, 7. So there are 7 electrons in the valence shell. It tries to get 1 electron to achieve stability. Its valency will be 8 minus 7 is equal to 1. In case of sulfur, its atomic number is 16. Its electronic configuration will be 286. So, sulfur gain 2 electron to complete its octet. Its valency will be 8 minus 6 is equal to 2. In case of silicon, there are 4 electrons in the valence shell, so its valency will be 4. Moving to the next, variable valency. Variable valency means some element can show more than one valency. These elements can lose different number of electrons in different compound depending on the situation. Why does it happen? Actually, some elements have more than one stable electronic state. They can lose electron from more than one shell or orbit, which is why they show different valencies in different compound. Like in case of iron, iron lose 2 or 3 electron. This happens because such element can lose electron from more than one shell. So variable valency means some element can show different valencies in different compound. Iron shows 2 or 3 valency. Copper shows 1 or 2 valencies. Now, coming to the next point, valency and chemical formula. Valency is invaluable for accurately writing chemical formula, often using the Criss-Cross method. We will understand it by following a few steps. In step 1, write down the symbols of combining elements side by side with the electropositive element. So let me quickly explain what electropositive mean. Electropositive element are those which like to give away electron and become positively charged, like sodium, magnesium, calcium. So these elements are positively charged element. Usually metals are electropositive in nature. So after writing the symbol of combining elements side by side, we will write the valency of each element below its symbol. Now, crisscross the valencies. The valency of first element become the subscript for the second element and vice versa. While writing formula, we need to remember few important points. First is, do not write 1 as a subscript in formula. Next is simplify the subscript if possible and use bracket only if a group of atom is repeated. Like in case of calcium nitrate. Calcium is positively charged. Calcium has +2 valency and nitrate is negatively charged ion. Here, nitrate is not an element, it's an ion. It is a group of atom. Now, crisscross the valencies, and the formula that we will get is CaNO3 whole twice. We need to write bracket here because there is a group of atom. NO3 is a group of atom. It's not element, it's an ion. Let's take an example of sodium chloride. In case of sodium, as we have previously learned, sodium has one electron in its valence shell because it tend to lose its electron, so it will get plus charge on it. And in case of chlorine, there are 7 electrons in the valence shell, so it tend to gain electron. To get stability, it will get minus charge. Now crisscross the valencies of both the element, and the formula that we will get is NaCl. As we have previously learned that we do not need to write 1 as a subscript in the formula. So the formula of sodium chloride will be NaCl. In case of magnesium oxide, magnesium is positively charged. It has +2 valency and oxygen has -2 valency. Now crisscross the valencies, and after simplifying the valencies, we will get the formula of magnesium oxide is MgO. In the next example, like carbon dioxide, carbon has 4 electrons in its valence shell and it tend to share all its 4 electrons to get stability. So its valency is 4 and oxygen has -2 valencies. Now crisscross the valencies and we will get the formula CO2. After simplifying the subscript, we will get the formula CO2. Here I am giving few more examples like water. Hydrogen has +1 valency because it has 1 electron in its outermost shell and it tend to lose its 1 electron. So it will get +1 valency. So hydrogen has +1 and oxygen has -2 valency. Now crisscross the valencies and we will get the formula of water is H2O. In case of aluminium oxide, aluminium has atomic number 13 and the electronic configuration of aluminium will be 283. So as we can see that there are 3 electrons in the valence shell. So it tend to lose all its 3 electron. So it will get +3 valency. And oxygen has -2 valency. Now crisscross the valencies and the formula of aluminium oxide will be Al₂O₃. Now in case of calcium hydroxide, calcium has +2 valency and hydroxide is a ion. It is not an element, it's a group of atoms, so we need to put bracket here. And now crisscross the valencies and the formula that we will get is calcium CaOH whole twice. We need to put bracket here because there is a group of atom. So we need to put bracket here. And the formula will be CaOH whole twice. So this technique ensures that total positive charge equal to the total negative charge in resulting compound maintaining electrical neutrality. So it concludes valency is a key concept in chemistry because it helps us to understand how and why atoms combine to form molecule and compound. It allows us to predict chemical formula, understanding bonding, and explain stability of an atom. Without valency, we would not be able to write correct chemical formula or understand reactions. So it's truly the foundation of chemical bonding and essential for learning further topics in the chemistry. I hope This video help you understand valency, octet rule, and how to write chemical formulas step by step. In the next video, we will practice some important questions based on this topic. So make sure to watch that too. Don't forget to like, subscribe, and hit the bell icon so you don't miss the next part. Bye bye.